Okay, so we found the VI of the window, becomes our VF from below the window, and now we want the VI with which we threw it. So we have the VF, we have the delta D, we have the A, we want the VI, so we would use VF squared is equal to VI squared plus 2A delta D, and then just bring your 2A delta D over. So VI squared will equal VF squared minus 2A delta D. So the VF is what you just found, 6.962, etc., squared, minus 2 times negative 9.81 meters per second squared, and the delta D down here is 3 meters, still going up, so it goes in as a positive. So the negative there will become a positive, and you'll end up adding. And before you take the square root, you should get 107.3294, and it looks like the 4 is repeating. Meters squared per second squared, take the square root, VI is equal to 10.36 meters per second. Okay? Alright, that's example 7. Last example. Number 8, dropping an object past a window or another point. So a chemistry textbook, you don't want to drop a good physics one. Chemistry textbook is dropped from the roof of a building and reaches the lab window 3 meters below. Okay, so here we have the roof. So this is going to be above window this time. And window again. So it says it's dropped, which means VI is 0. And of course it's falling, so A is 9.81 meters per second squared down. And it reaches the lab window 3 meters below, so delta D is 3 meters, also down. If it takes 0.2 seconds to pass the lab window, so now we're down here, the time for the window is 0.2 seconds. A down here is still 9.81 meters per second squared. What was the height of the window? So you're looking for delta D. Okay, and again, what connects above the window and the window? Well, exactly the same thing that connected up here, only this time, since it's falling, this is going to be the VF above the window, and it's going to become the VI of the window. So if you can find one, you'll have the other. So we only have one unknown in the top part, so let's start there. We have a VI and a delta D, and we want a VF. So VF squared is equal to VI squared plus 2A delta D. The VI goes to 0. So, and everything this time is down. So we don't have to worry about positives and negatives. We can just call down negative. So it's equal to 2 times 9.81 meters per second squared times 3 meters. And don't forget to take the square root. So before the square root, I think you get 58.86 meters squared per second squared. And after the square root, you get 7.672 meters per second, also going down. So this then becomes the VI of the next section. And the next section, what's the height of the window? You have the VI now. You have the time, you have the A. So just use delta D is equal to VI delta T. 1/2 A delta T squared. So delta D is equal to that 7.672 meters per second you just found. It told us it was 0.2 of a second plus 1/2, 9.81 meters per second squared, 0.2 of a second squared. Okay, and when you do this, first term is something like 1.5344 meters, and the second term is 0.1967 meters. Add them up and you get the height of the window to be 1.7306 meters, and you are done. Okay, so those are all our examples, but they're not all our questions. So tonight, if I would love it if you would work on number 5 and 6 on the harder problems with acceleration. We've done up to number 4. And on the back of the sheet, number 4 and number 5. Okay, so 4 questions, 5, 6 on the front, and on the back 4 and 5. I'll do videos of these tomorrow, and then I'll have a new sheet. Even though this one says the last, I think you need more practice. Please try these. It looks easy when I do it, but setting them up is the key, and that's what you need to practice with, okay? Thank you.